Hey guys, today we're going to be doing math together. We're going to be looking at topic 12, lesson 3. We're going to compare decimals. Our learning target today is I can compare decimals by reasoning or thinking about their size. Okay, so today I'm using my interactive student edition in Pearson Math. You can use yours so that you can use the tools I might be using, or you can certainly do it in your workbook there at home. Let's take a look at what we have today. We're going to start with the solve and share, which is right in your workbook too. It says, a penny made in 1982 weighs about 11 hundredths of an ounce. A penny made in 2013 weighs about 9 hundredths of an ounce. Which penny weighs more? Of course, I circled my important numbers. I underlined my question, which is really my task, my job for this problem. It says we can solve this problem any way you choose. So, the question, which penny weighs more? Does this one weigh more? Does this one weigh more? This is a comparing problem. So, let's fill in our information here. We have a penny that's 11 hundredths of an ounce. We have a penny that's 9 hundredths of an ounce. And because we're comparing, I'm going to put the big circle in the middle. That's where we're going to put our greater than sign, our less than sign, or our equal to sign, depending on what our answer is. Let me switch to a different color here. When we compare numbers, just like when we compared whole numbers, you look at the largest place value slot first. So let's look all the way to the largest slot. That would be the ones place. For both numbers, I have a 0 digit in the ones place. Think about how we used to do whole numbers. Is this very useful? No, in class we would have said this is useless. I can't use 2 zeros to compare this number. They're the same. We will jump to the next largest place value slot, which is going to be the 10th place. So in this number, I have 1/10 and I have 0/10. Well, certainly 1/10 is greater than 0 or no tenths. That means that my little alligator wants to eat the number with 1/10. That is the greater than sign. So I would read my answer, 11 hundredths is greater than 9 hundredths. Does it matter what's in the hundredths place in this case? Not really. Tenths are larger than hundredths, so really I can just compare those. That's like saying, does it matter if I have 1 penny or 9 pennies? No, it really doesn't matter if I have 1 penny or 9 pennies. Not if I have a dime worth 10 cents on this side and no tenths on this side, no dimes. So we're done with this problem. So let me erase this. We're going to jump down together and we'll look at the look back problem. It says, Simon and Danielle are eating oranges. Danielle says, because we each have 75 hundredths of an orange left, we have the same amount left to eat. Do you agree with Danielle? Explain. This is a two-part problem. Womp womp. Explain. We'll have to write sentences that sound mathy. Okay? So let's take a look. I like to kind of draw it all out. So over here I have Simon. And Simon has 75 hundredths of an orange. Over here with 75 hundredths of an orange is Danielle. And we're going to compare these two numbers to decide if they have the same amount left to eat. So I look at the ones place first. They're the same. They're useless. I can't use that to compare. I'll jump next door to the tenths place. They both have 7/10. Well, that's not useful. That's useless. I can't compare those if they're the same. And then last in the hundredths place, I have 5 hundredths each. Well, that's not useful either. They're the same. If the two numbers have exactly the same value, my answer is equal to. Now, there's a catch. What if Simon's orange over here were really large orange? And what if Danielle's orange over here were a really tiny orange? Is 75 hundredths of Simon's orange going to be equal to the same size, same amount as 75 hundredths of Danielle's tiny orange? No, it's actually not. He has way more because his orange is larger. So our answer only works out, yes, the same, if their oranges are exactly the same size. So let's answer now. So do we agree with Danielle? Well, yes, they are equal. Except if the oranges aren't the same size. I'm running out. I hope you have enough room where you are. I remember to use a capital letter, and I remember to use punctuation in my math explanation here. All right, guys, let's jump over to our next page together. I'll erase, and you'll flip your page. Did that work? Not so great. Okay, let's see. Okay, we did this one, right? No, we didn't do this one. Great. This is our visual learning problem. That's the one that you're going to do with the visual learning video on Pearson Math. So I'm going to scroll all the way down to the convince me. Let's do this one together, okay? So let me get my marker. It says convince me. Write 4 different digits in the blank spaces to make each comparison or comparing problem true. Explain your reasoning. Okay, so let's look at the first one. In the first one, the tenths are missing and the tenths are missing. And we want our first number to be less than the second number. Well, tenths and tenths, they both have nothing, 0, in the ones place. So next door in the tenths place, if I want my first number to be less than, it needs to be a smaller digit. So it really doesn't matter what I put in this first space, as long as whatever I put in this space, like 1, is less than the digit I put in the second number, like 2. I could put 4 and 5. I could put 8 and 9. It doesn't matter what I put so long as the first digit is less than the second one. Now, you might be asking yourself, but Miss Hubbell, there's an 8 in the hundredths place. There's a 7 in the hundredths place. Does that matter? Well, does it? Does it even matter what's in the hundredths place if the tenths place slots are different? No, it doesn't, because 18 hundredths is less than 27 hundredths. Let's jump next door. Let's look at this one. It says 5 tenths, we don't know how many hundredths, is greater than, we don't know how many tenths, and 9 hundredths. Okay, well, the zeros in the ones place are the same. And here in the tenths I have 5, and here I don't know how many tenths. But I want the 5 to be greater than. So I have to pick something that